All right, let's take a look at the section 3.8 homework. Number 3 here. It is given that we have circle O, which means that OY is a radius. OZ is a radius. All radii in the same circle are congruent, so OY is congruent to OZ. It's also given that YO is perpendicular to YX. We have a 90-degree angle there. Also, ZO is perpendicular to ZX. We have a 90-degree angle there. We were asked to show how we're able to conclude that yx is congruent to zx. So I drew in a construction line here, OX. Notice we have two right triangles then. We have a leg, OY, congruent to a leg, OZ. We have a hypotenuse congruent to a hypotenuse, and OX being congruent to itself. That is the reflexive property. And then we're able to conclude that triangle YOX, Y is where the right angle is. We travel down the one tick mark side to get to O, and then X is congruent to triangle ZOX. Z is where the right angle is. Travel down the one tick mark side to get to O, and then X travel down the shared side there. So this is a correct triangle congruency postulate. And then finally, we're able to conclude that YX is congruent to ZX through CP/CTC. So this one's kind of a funky problem because typically on these conclusion problems we have like one reason or whatever. This is a little bit more like a proof conclusion problem hybrid. So that's what's going on in 3. Taking a look at 4. It is given that AE, there's a tick mark there on AE, is congruent to CF. It is also given that AB is the side on the bottom here, is congruent to CD, that side on the top there. And angle BFA is a right angle, so that's marked up. And angle DEC is a right angle, that is marked up as well. So we have a right triangle in DEC, we have a right triangle in BFA. We are trying to prove that angle CDE is this angle right here where my cursor is, so that is an angle in that right triangle, is congruent to angle ABF. Angle ABF is right there where my cursor is, so that is also an angle inside that other right triangle. So I notice right away I've got AB congruent to DC. That is the hypotenuse congruent to the hypotenuse. That's nice. AE is not an entire side, CF is not an entire side, but side FA is comprised of AE and EF. Side EC is comprised of EF and FC. So EF shows up in both of those. The addition property tells us that when a segment, meaning EF, when a segment EF is added to congruent segments AE, FC, the sums must be equal. So we know that AF must be congruent to EC through the addition property. So our plan is to use the addition property. Then we're going to show these two triangles are congruent using hypotenuse leg. So the top triangle DEC congruent to the bottom triangle BFA. That's hypotenuse leg. And then we're going to use CP/CTC, corresponding parts of congruent triangles are congruent to show that CDE is congruent to ABF. So let's get going. First, the given information, AE is congruent to CF. That's given. I went ahead and used the addition property because the addition property builds off of that information in statement 1. Didn't have to do it this way, but I chose to. AF is congruent to CE. AF is congruent to CE. If a segment is added to congruent segments, then their sums must be equal. So that's how we know AF is congruent to CE. Up next, AB is congruent to CD. You see that right there in the given information. That's our two hypotenuses, right? So that's given. Also, angle BFA and angle DEC are right angles. That is given, meaning we have a right triangle on top and bottom. Okay, so we have two right angles, so we don't have to explicitly state that we have two right triangles. That's good enough for me. We're now able to show that triangle BFA is this bottom triangle, is congruent to triangle DEC, that's this top triangle, by the hypotenuse leg congruency postulate. Double check your congruency statement. What is B? B is where the hypotenuse, let's do this. B is where our hypotenuse of AB meets this like unmarked side of BF. We have no information on BF. D is where the hypotenuse meets its unmarked side of DE. So D and B are corresponding. I put B first, so D needs to go first. I put F second. So going from B to F, I traveled down that unmarked side to our right angle. So from D, travel down the unmarked side to the right angle at E. So F and E, they have to be corresponding and congruent. And then finally, to get from B to A, I travel down the 2 tick mark side. To get from D, traveling down the 2 tick mark side, I get to C. So A and C are corresponding. So hypotenuse leg congruency postulate, make sure your congruency statement is correct. Finally, we're able to conclude what we wanted to conclude, which is angle CDE is congruent to angle ABF. What is CDE? That is third, first, and second. ABF, third, first, and second. So checks out. Remember, it doesn't have to be third, first, and second. It could be third, first, and second, or second, first, third. Remember, the way we write the angle is the same forward as backwards. In other words, you could have said CDE is congruent to FBA. That would work too. But it worked out nicely in this one. All right, that was example or problem 4. Taking a look at number 6 here, GH is congruent to GK. I've marked that up with the circles. GH is congruent to GK. It is also given that GJ is an altitude. So here's GJ. If that's an altitude, we have a 90-degree angle here at GJH and 90-degree angle at GJK, meaning we have a right triangle on the left and a right triangle on the right. That means GJ is a shared side of both of these triangles, so GJ is congruent to GJ. That is a reflexive property. And we're able to prove these 2 triangles are congruent through the hypotenuse leg congruency postulate. So here you see that given information. GH is congruent to GK, that's given, marked up on the figure. GJ is an altitude, that is given as well. Angle GJH and angle GJK are right angles. That's the definition of altitude. That is good enough to show that we have 2 right triangles. And then we can use the hypotenuse leg postulate. GJ is congruent to GJ. That's a reflexive property. And triangle GJH is congruent to triangle GJK. Always check your congruency statement. That's the hypotenuse leg. So that's hypotenuse leg there. GHJ congruent to GJK, those 2 triangles there on statement 5. What are we trying to show? We're trying to show that GJ bisects angle HGK. And I realize now I interpreted this problem incorrectly. It's a quick fix, not a big deal. If angle HGK has been bisected, that means HGJ must be congruent to angle KGJ. So angle HGJ is congruent to angle KGJ. That is still corresponding parts of congruent triangles are congruent. So yeah, just learn from my mistake and read carefully, go slow, check and double check your work. I guess this is my version of double checking as I'm going over it here for the video. And then finally, number 7, ray GJ bisects angle HGK. That's the definition of bisect. That was number 6. All right, here on 14, it is given that the measure of angle A, here's A, is larger than the measure of angle C, so A is bigger than C. What that lets us know is the opposite side, BC, is longer than AB. Remember, the longer side is opposite the larger angle, so larger angle is A, longer side is BC, smaller angle is C, shorter side is AB. So let's find the restrictions on the value of x. First off, 4x plus 48 has to be less than 8 minus x. We solve for x, and we see that x is less than negative 8, but there's more. Remember, these have to be positive lengths, right? So BC has to be greater than 0, and AB has to also be greater than 0, so let's solve that accordingly. Well, when we solve for 8 minus x is greater than 0, I added x to both sides, and we get 8 is greater than x, or you flip it around, x is less than 8. Well, x already has to be less than negative 8, so that doesn't add any restrictions. Let's take a look at what new restrictions are added when 4x plus 48 is greater than 0. And we get x is greater than negative 12. So x has to be less than negative 8, but greater than negative 12. So negative 12 is the low end, x has to be greater than that, and negative 8 is the high end, x has to be less than that. All right, number 15 in the diagram, PQ is congruent to QR. Here's PQ, here's QR. We're also told that QS is perpendicular to PR. Notice PR is directly on the x-axis, meaning it's perfectly horizontal, which means QS has to be perfectly vertical. So if Q is the 0.49, S has to be the 0.40. So we are not moving left or right at all from the 0.49, but we're just going straight down to the x-axis, so that's going to be the 0.40. B, explain why PS is equal to SR. Well, if angle QPR is congruent to angle QRP, and the reason that is the angle side theorem, right? So PQ is congruent to QR, their opposite angles must be congruent as well. Also, notice QS is shared by both of these triangles, so these triangles are congruent by hypotenuse leg, and if they're congruent, PS and SR, they are corresponding parts in congruent triangles. So let's write that down. Alright, so as I wrote this down, I realized there was another way to do it as well. So I'll talk about both ways, and I think the other way might actually be better. So PQ is congruent to QR, PQ congruent to QR, that is given. I said that QPS is congruent to QRS, those two angles, that's the angle side theorem. This is a step you did not need. QS is congruent to QS, that's the reflexive property. As you can see, we have right angles here, so it is understood these are right triangles. So I used hypotenuse leg, and as I wrote that down, I realized that the angle side theorem here, these two angles being congruent, QPS congruent to QRS, that doesn't help us prove the hypotenuse leg theorem, so this would be an extra step here. So it's a true relationship, but it doesn't help us build our case for using the hypotenuse leg theorem for triangle QPS being congruent to triangle QRS. All you need for the hypotenuse leg theorem is the right angles, right? QS congruent to QS, that'd be the leg using the reflexive property, and QP congruent to QR. Those are the two hypotenuses that are congruent that was given to us. But then, once you know the two triangles are congruent, we do use CP/CTC to show that PS is congruent to SR. So again, this is an example of an extra step, something that is true, but it doesn't really help you build your case. On to C, find the coordinates of R. Well, from P to S, we're going from x equals -2 to x equals 4. That's a distance of 6, which means S to R is also a distance of 6. So if we're moving to the right, that's the x direction. We're going to add to our x coordinate. 4 plus 6 gives us 10. So we're at 10, 0 for point R. Point R is at 10, 0. D, find the area of triangle PQR. Area of a triangle is 1/2 base times height. Our base is 6 plus 6, which is 12. Our height is the height of QS. The height is going to be that perpendicular segment. That height is 9. So the height is 9. So the area of this triangle is equal to 1/2 multiplied by 12 multiplied by 9. So half of 12 is 6. 6 multiplied by 9 is 54. So 54 units squared for the area. On to 19. Which of the triangles below are congruent? Part A. Part B, if two of the triangles are selected at random, what is the probability that they are congruent? Okay, let's take a look at A. A, we have 1 tick mark for a leg, 2 tick marks for a leg, we have a 90-degree angle, we have a 2 arc angle, that's A. Jump down here to E. I notice I've got the 2 tick mark side for the leg, the right angle, and then the 2 arc angle here. So E and A, they are congruent by what? Think about what they're congruent by. It's angle, side, angle. Angle, side, angle. It's not hypotenuse legs. I have no information on this hypotenuse here for triangle A. So A is congruent to E. Right, so let's put that over here. So we'll say triangle A is congruent to triangle E. And now let's fill in with those corresponding parts. If these are congruent, let's put one tick mark here on this leg, and let's put a circle here on that hypotenuse. Now with this in mind, is B congruent to A? Take a look at B. Well, we got the one tick mark for the leg, we got the 90-degree angle, we've got the hypotenuse is congruent, so these two are congruent by hypotenuse leg. So we're going to throw in here triangle B is also congruent. And now let's mark up everything on triangle B as well. 2 arcs, 2 tick marks. Okay, let's take a look at C. All right, C. So we have 1 tick mark, 1 tick mark, circle, circle, 2 tick marks, 2 tick marks. B and C are congruent by what postulate? Side, side, side. So let's throw triangle C in here as well. Okay, let's take a look at D now. D, I don't know if I have a right angle here or not. I do not have 1 tick mark congruent to 1 tick mark. I have the, let's compare this to A. So 1 tick mark congruent to 1 tick mark, the circle congruent to the circle, and then the 2 arc angle congruent to the 2 arc angle, but this is angle side side. Angle side side is not one of our triangle congruency postulates. This is not an included angle, therefore we can't use side angle side. So D is the only one that is not congruent to the others. So which of the triangles below are congruent? So there's part A. Triangle A is congruent to triangle E, is congruent to triangle B, is congruent to triangle C. Now on to part B. If 2 of the triangles are selected at random, what's the probability that they are congruent? So 4 out of the 5 are congruent. So on the first draw, it's going to be 4 out of 5. On the second draw, we have 4 triangles remaining, 3 of which are congruent. 5 times 4, we get 20. 3 multiplied by 4, we get 12. These are both divisible by 4. 20 divided by 4, we get 5. 12 divided by 4, we get 3. So 3/5 is the probability that 2 angles selected at random are congruent. All right, that's it for this assignment, and that's it for all the Chapter 3 homework. We do have our test review, so that'll be found in OneNote, so make sure you give that your best effort as well. I already mentioned when the test was. That can be found on Google Classroom as well. All right, thank you very much. Have a great day.